Hello, my name is Joao Lopes from NXP Semiconductors. I'm here to present you a 5G Alliance for Connected Industries and Automation Endorsed Testbed, which is called Towards Purposeful TSN over 5G, integration of OPC UA and TSN into 5G networks. This presentation has 4 parts. The first one, introduction, is where I introduce myself and 5G CIA. The second, I will guide you through the most relevant features that 5G technology has to offer for industrial automation. Then the third part is about the testbed description, so what we did, who we are, and what we tend to do in the future. And then the fourth part I will conclude. As said at the beginning, my name is Joao Lopes, and I'm a principal engineer in system innovation at NXP Semiconductors. I'm also the vice chair of the networking working group at OPC Foundation. And finally, I'm the liaison officer towards OPC Foundation from 5G CIA. And what 5G CIA stands for? Alliance for Connected Industries and Automation. We are a global organization with over 80 members from industry to academia, spread all over the world. We have 5 working groups, from use case requirements to industrial 5G in practice. We have several publicly available white papers on 5G usage for industrial automation, different use cases, you name it. We also have internal documents with a lot more detailed information, but in order to access them, you need to become a member of 5G CIA. Finally, there are also several 5G CIA endorsed testbeds to foster 5G usage into the industrial automation. Now that we are done with introductions, let's see about 5G technology and 5G in the industrial automation. The first important aspect is that 5G, as well as other technologies that OPC UA makes use of, it is SOSI layered. And with that, it is ensure the interoperability across layers and also across verticals. This will allow you to reduce the development costs because you can focus only on what you want to develop. And besides that, it can also increase the total addressable market of what you develop because it can span over different verticals. So now, why 5G for the vertical industrial automation? Well, the first point is that 5G can have different communication profiles just by configuration. You can support both low data rate on high data rate, low latency, high latency. It is a matter of configuration. The second topic is that since release 16 in 2020, 5G can support natively several TSN features. And this allows you, as third point, that you can make a seamless integration in 5G in a network because you can configure 5G to behave like a logical TSN bridge. Okay, but how can 5G behave as a TSN logical bridge? Well, 5G operates as a transparent TSN logical bridge. It has on the device side, the user equipment side, the so-called device side TSN translator. And then on the network side, it has the network side TSN translator. And these are the ingress and egress ports that are configured by the TSN application function. This TSN application function gets the configuration for these ports, these translators, directly from the CNC. And therefore, the 5G network can behave as a logical TSN bridge exactly like the normal TSN bridges. There are further features that make this possible, and you can see them here listed. There are a few here. And what about 5G synchronization? So 5G supports TSN time synchronization. That means that it supports IEEE 802.1as across 5G based Ethernet links with Ethernet PD sessions. And with that, 5G is a time-aware system, and it has also actually a time error that is below 1 microsecond. So, but that does not mean that 5G has the same system time as the TSN network outside 5G. They may have different notion of times. And in order to synchronize, what they do is that there is a conversion from the TSN time domain into the 5G time domain. So if there is a frame that goes through the network side TSN translator, then it gets converted from the TSN time domain into the 5G time domain, and then traversing complete 5G system and going out through the device side TSN translator, then gets converted back from the 5G system clock to the TSN system clock or time domain. And this implies also that both on the network side, meaning the network TSN translator at the UPF side and the GNOT be included, and then on the device side with the UE and the DSTT, they all need to be synchronized with a 5G internal system clock. And now coming to the testbed descriptions. The objective of this testbed is very clear. We want to enable TSN over 5G, and specifically for the industrial automation vertical. And you use that as test vehicle, the OPC UA FX. And in order to do that, and this is not one shot, we are going to develop this further and further throughout the next 2.5 years. We first try to understand what are the priorities, what is more stringent and more relevant from industrial automation perspective that TSN and 5G needs to support. What are the missing features? And from there, we try to understand, okay, what are the implications? How much work does it take to deploy these features that are missing? So we cross the priorities with a workload. And from there, we derive the sequence of the features that are going to be deployed. And then we do them. We deploy these features step by step. And we do that, and as we do that, and we do also interoperability tests. As you can see on the bottom, we have 8 companies or academia participating in this testbed, and they all have their part on the system, and so they all have to be interoperable. And at the end, the system needs to work. So once that we have these features implemented, by connecting all the components on the network, we validate this interoperability in this end-to-end system. And once doing this, then we go to another fair, other fairs will come, and we disseminate the results, as well as here in this webinar. So the ultimate goal is to use and push 5G technology, 5G products, and the ecosystem. So now the question is, what exactly did we do in this first 5G CIA endorsed testbed? So as you can see here on your left side, this is a map of the Hanover Fair, and at all 14, it was the booth from 5G CIA. At all 9, it was the booth of OPC Foundation. So what we did was we connected these different fair booths, and in order to illustrate that, we enabled 2 different use cases, altogether featuring 4 cameras for monitoring, supervising what was happening in wall hall when you were on the other hall, and the other way around for each of the 2 use cases. And each use case had a separate real-time control network. So just to recall the membership, OT companies that supported this testbed were Schneider Electric, Mitsubishi Electric, Moxa, and Belden. And then IT partners, Radisys and NXP. Academia, IMRC and IFAC, and organization you can see is 5G CIA and OPC Foundation. So in here you can see one of the demonstrators. This is the number 1. And what happens is that there at the Hanover Fair on the OPC Foundation, there was a setup with a joystick and a camera and a video monitor with a video server, all of them connected to a 5G gateway. So the data that was being sent by the joystick, by the camera, and being collected by the video server, they were all sent through the 5G gateway to the GNOT B. And then from the GNOT B that was located, GNOT B is a base station, by the way, Then from the G node B located at OPC Foundation, there was a dark fiber connection to the core network that was located at the 5G SCIA booth at all 14. And this core was then connected to the other base station, the other G node B, that was then transmitting this data, so the camera information and the joystick, to the video and to the crane. So from the joystick you could control the crane, from the camera you will transmit the images to the video server. And that means that when you were at the OPC Foundation site, you could control the crane that was located at the hall, but you could also see from the OPC Foundation booth the crane moving, because there was on the 5G SCIA booth also a camera filming the crane movements. From the other side, from the 5G SCIA side, you could see the crane moving, and you could also see the video server or the monitor that was transmitting the image captured by the camera, meaning if somebody was moving the joystick, you could see somebody moving the joystick from the 5G SCIA booth. Okay, and what you can see here is the real implementation of what those pictures were depicting. So you see at the OPC Foundation side, you see there is a joystick and there is a camera. And you can also see the monitor. And on the 5G SCIA side, you can see very clearly the crane, it's also yellow, and there is also a monitor that is transmitting the images that are being transmitted by the camera at the OPC Foundation booth. And now the demonstrator number 2, which is a bit different. So what you have here is at the OPC Foundation booth, there is the UA FX demo wall, and there are different controllers that can perform altogether 4 different tasks. It is either bottle washing or filling or capping or labeling. And if you look at the step bottle filling, there is an additional controller. So every one of the other steps have 2 possible controllers, whereas in the bottle filling there is a 3rd controller. So, and what you can do at the OPC Foundation booth is that you can define which controller is going to perform each of these 4 tasks. And then this mock-up starts. But now the difference that with this 3rd additional one, the bottle filling can be performed by a controller that is not at OPC Foundation booth. Instead is a controller that is remote. It's on the 5G SCIA booth. So at the end, what happens is that the information goes from the bottle washing controller through 5G to 5G SCIA booth, and then the remote controller processes this information, so meaning it performs the filling task and then goes back over 5G to the OPC Foundation booth, then goes to the next step, which is bottle capping and then bottle labeling. So at the end, what we are showcasing is that it doesn't really matter if it is located on the spot or if it is remote. You can perform over 5G already control tasks. And similar to the demo number 1, you have one camera filming what is happening and at each of the booths, and you have monitors that show what is happening on the other booth, and then all this information is being conveyed over the 5G gateways, through the G node Bs, over the core network, to the other G node B and to the other 5G gateways, and so on. Okay, and then here you see again pictures of what was really implemented. I think that maybe you already have seen this OPC UA FX demo wall, and this is the demo wall that was communicating, and it was at the OPC Foundation booth, and then at the 5G SCIA booth you can see on the right hand side there is a controller. So half of it is the lower part is red, and this is the third controller that is not located at OPC Foundation booth, instead at 5G CIA booth, but it is remotely over 5G connected to the OPC Foundation's UA FX demo wall, and taking part, if configured as such, in the control application that is being represented here. Coming to the conclusion, I would say that as one challenge was the fact that we only had 20 MHz bandwidth for the communication in the testbed. Another challenge was the fact that we had several manufacturers involved in this end-to-end 5G system, so interoperability was something that we have to take into consideration. And lastly, but not least, the hardware and software used were sometimes in a pre-launch phase. Nevertheless, the results were that we were able to support 4 quality video streams and 2 real-time control streams. And still the connectivity was stable during the fair. So I would say as an outlook that these real-world use cases in this testbed demonstrate 5G benefits. And the fact that we used products in a pre-launch or launch phase states that these use cases can be served today. And further use cases will also be covered in the upcoming testbed setups in the coming 2.5 years. And with that, I finish my presentation. I thank you for your attention. If you'd like to join this testbed, then you can always reach out and let's see what we can do together. Thank you.